show that the rectangular solid of maximum volume that can be inscribed in a sphere, is a cube. Solution. See, let's understand the problem. What is that? There is a rectangular solid with maximum volume which is inscribed in a sphere. Then that rectangular solid becomes a cube. Cube means, you know, okay, all the dimensions are same. So let me take, this is the circle. Okay, I cannot draw a three-dimensional figure. So listen carefully to understand the concept. Rectangular solid, nothing but rectangular box of maximum volume that can be inscribed in a sphere is a cube. Let me convert the problem into 2 dimension. Actually, this is 3 dimension. Convert similar problem in 2 dimension. What is that? Show that the rectangular having maximum area, that can be inscribed in a circle in place of sphere, circle in place of rectangular solid, just rectangle with maximum area is a square. I have to prove this, right? So actually the rectangular box inscribed in this sphere, I'm taking like this. Okay, I'm taking like this. And this is the center of the sphere. Let me take sphere, center is origin O, because I have to take the dimensions x, y, z. I have to consider the dimensions x, y, z. So now this is the x-axis and this is the y-axis. If I consider 3 dimension, this will be the z-axis. So this is x-axis, this is y-axis, and this will be the z-axis. Instead of rectangular box means I have to draw like this, right? I have to draw like this and join all these. So to understand the concept, I'm taking only rectangular box shape like this. Now, since this is x-axis, from the origin, what is this distance becomes? Let us consider this distance is x. Obviously, what is this distance is also x. Therefore, what is the length of the rectangular box? What is actually generally, if rectangular box is given previous problem, we have taken x, y, z be the dimensions of the rectangular box. But when this rectangular box is inscribed in the sphere, the situation is like this. That means from the origin, the distance is here x, and from here also x. So what is this total length becomes? Total length of the rectangular box becomes how much?
2x.
2x. So that is the logic. Now, when rectangular solid inscribed in the sphere, don't take x, y, z be the dimensions of the rectangular box. What are the dimensions? This is 2x. Same logic. This much distance is what? Y. And this much distance is what? Y. So what is this total length? Total this width? 2y. Same logic, 2z. Is that clear? So first introduction is what? Let 2x, 2y, 2z be the dimensions of the rectangular solid. Dimensions of the rectangular solid. Rectangular solid which is inscribed in the sphere. This is the condition, which is inscribed in the sphere. Okay, now dimensions are over. And what is given? Show that rectangular solid of maximum volume. That means I have to inscribed in the sphere. Let me consider the sphere as x square plus y square plus z square equal to something, r square. x square plus y square plus z square equal to r square, because origin I am taking 0, origin as 0 0 0. Okay, now we have to maximize the volume. We have to maximize the volume. What is the volume? V equal to how much? X into y into z, that is 2x into 2y into 2z, that is equal to 8xyz, subject to the condition. What is the condition is given? Subject to the condition, the circle equation, right? Xyz are connected by the relation, subject to the condition phi of xyz is equal to how much? X square plus y square plus z square equal to r square. Okay, therefore what is the Lagrange's function? Therefore the Lagrange's function is L x y z lambda. Only one condition is here. So what is this? The function 8xyz plus lambda into the given condition. What is that condition? X square plus y square plus z square minus r square. Now the necessary conditions for maximum are, what are those? Partial derivatives of L with respect to dou L by dou x equal to 0, dou L by dou y 0, dou L by dou z 0, and with respect to Lagrange's multiplier dou L by dou lambda also 0. Okay, so first one I am taking dou L by dou x equal to 0 implies 8yz plus 2 lambda x equal to 0. First equation. Next one, dou L by dou y equal to 0. Let me take this as the first equation and this is second equation. Y means xz plus 2 lambda y equal to 0. And the third one, dou L by dou z equal to 0 implies 8xy plus 2 lambda z equal to 0. 2 lambda z equal to 0. This is 3 and this one 4. And lastly, dou L by dou lambda equal to 0 means what? Dou L by dou lambda, this lambda derivative one, you will get this one equal to 0. So what is this one? X square plus y square plus z square equal to r square. This is equation 5. Now I have to solve these three equations, 2 3 4 4 equations. So what I'm doing, to here 8yz is there, here 8xz is there. So here x is missing, here y is missing. So 2 into x minus 3 into y, what this gives? 8xy gets cancelled, 8xyz gets cancelled, and this is multiplied by what? X. So I'm getting 2 lambda x square minus 2 lambda y square equal to 0. So this is equal to x square equal to y square. So what is the one condition? X equal to y. Same logic, this one and this one. Multiply 3 by, what is that? Multiply 3 by y and 4 by z. So 8xyz gets cancelled. We are getting 2 lambda y square minus 2 lambda z square equal to 0. Okay, that is, this implies y square equal to z square, y equal to z. Hence, what I'm getting? X equal to y and y equal to z. Therefore, the rectangular box, all the dimensions are equal means it is a cube. Rectangular box with a maximum volume, that can be inscribed in a sphere, is a cube, since all the dimensions are equal. This is one problem. Okay, and next one, in exercise, that's also easy. Yeah, next problem, let me consider two conditions problem. Find the extreme values of f of xyz equal to 2x plus 3y plus z such that x square plus y square plus x square plus y square equal to 5 and x plus z equal to 1. X plus z equal to 1. Solution. Here the function which is to be maximized or minimized is 2x plus 3y plus z, where x, y, z are related by or connected by the conditions. What are the conditions? I'm taking like this. First one, phi 1 of xyz is equal to x square plus y square equal to 5. Phi 2 of xyz is equal to x plus z equal to 1. Therefore, since there are two conditions, define the Lagrange's function as L of first three variables. Since two conditions are there, two multipliers. So let me write f of xyz plus lambda 1 into phi 1 of xyz minus c1 plus lambda 2 of phi 2 of xyz minus c2. Okay, let us substitute L of xyz lambda 1 lambda 2 equal to, what is the first function is what? 2x plus 3y plus z plus lambda 1 into, what is the first condition? X square plus y square minus 5 plus lambda 2 into x plus z minus 1. Equation 1. Here lambda 1 lambda 2 are Lagrange's multipliers. Okay, now the necessary conditions for extremum means maximum or minimum. The necessary conditions for extremum are dou L by dou x equal to 0, dou L by dou y equal to 0, dou L by dou z equal to 0, and parameters dou L by dou lambda 0 and dou L by dou lambda 2 is also 0. So one by one, let me write. First, dou L by dou x equal to 0 is, this is 2 plus 2 lambda 1 x plus lambda 2 equal to 0. Equation 2. Dou L by dou y equal to 0. That means 3 plus 2 lambda 1 y, that's it, equal to 0. There is no y in the second condition. Next, dou L by dou z. Dou L by dou z equal to 0. What is this? What is this? Z value 1 and lambda 2 is there. So 1 plus lambda 2 will be there. Is that correct? Yes. 1 plus lambda 2 equal to 0. Equation z is then 4. Next one, dou L by dou lambda 1 0. That is nothing but x square plus y square equal to 5 you will get. Next, dou L by dou lambda 2 equal to 0. Then the other condition you will get x plus z equal to 1, 6. Okay, these are the conditions completely. Now I have to solve these equations. First one, from 4, what I am getting from 4, lambda 2 equal to minus 1. This is fixed over. Now from 1, then from 1, what is 1 implies? See, lambda 2 is known, therefore 2 plus 2 lambda 1 plus minus 1. 2 plus 2 lambda 1x minus 1 equal to 0. That means what? This is 1. So lambda 1 equal to what you will get, so not x1, x equal to what you will get, this is x equal to this is 1, so minus 1 by 2 lambda 1 you will get, minus 1 by 2 lambda 1. Same logic from the second equation. What is third equation? From the third equation, what we have, third equation, 3 plus 2 lambda 1 by 3 plus 2 lambda 1 y equal to 0. From this, what is y equal to minus 3 by 2 lambda 1, minus 3 by 2 lambda 1. Now I know x value, y value in terms of lambda 1. Let us substitute here. Substitute x and y in equation 5. Substitute xy in equation 5. So what is 5? X square plus y square equal to 5. This implies 1 by 4 lambda 1 square. You will get lambda 1 value now. 1 by 4 lambda 1 square equal to 5, right? So 4 lambda 1 square is the LCM, equal to 10 by 5, that is 2. That implies what is lambda 1 value? What you are getting, lambda 1 square equal to 1 by 2. So what is lambda 1 value? Plus or minus 1 by root 2. Plus or minus 1 by root 2. So there are, you are getting 2 points here maybe now. Therefore, when lambda 1 equal to 1 by root 2, what is x value? What is the substitution? Minus 1 by 2 lambda 1. So minus 1 by 2 lambda 1. So 1 by root 2. That is equal to minus 1 by root 2, x value. Minus 1 by root 2. Right? Next one, what is the y value? Y is what? Y is what? Minus 3 by 2 lambda 1. Minus 3 by 2 lambda 1. That is minus 3 by root 2. Y value is over. X value, y value. And z value I have to get. See how to get z value from equation 6. What is 6 implies? Now 6 implies x plus z equal to 1. So z value is what? 1 minus x. Therefore z value is what? 1 minus x, means 1 plus 1 by root 2. 1 plus 1 by root 2. So x, y, z values are over for lambda equal to 1 by root 2. Now negative 1 by root 2. When lambda 1 equal to negative 1 by root 2, what is x equal to? Minus 1 by 2 into negative 1 by root 2. That is 1 over root 2. Isn't it? Right. And coming to y, this is minus 3 by 2, 1 by root 2. This is negative. So this is 3 by root 2. And what is that equal to? 1 minus x. So 1 minus 1 by root 2. 1 minus 1 by root 2. These are the values. Okay. Therefore, what is f of z? Therefore, we have how many stationary points? 2 stationary points. 2 stationary points. What are those? First one is corresponding to 1 by root 2. Corresponding to 1 by root 2. What are x value? This is z value. This is y value. And this is x value. Minus 1 by root 2. Minus 3 by root 2. Minus 1 by root 2. Minus 3 by root 2. 1 plus 1 by root 2. And another one is what? Another one is what? 1 by root 2, 3 by root 2. And 1 by root 2, 3 by root 2, 1 minus 1 by root 2. This is another point. Take this as A and this point as B. Therefore, f of x, y, z. What is the function f of x, y, z? What is this? 2x plus 3y plus z. This one at A. This entire at A, point A. Substitute this value. This is equal to 2 into x value is 2 by root 2. Y value, sorry, this is minus 3 into minus 3 by root 2. And z value 1 plus 1 by root 2. So this is what? Minus 2 minus 9, minus 11 by root 2 plus 1 by root 2 plus 1. Isn't it? Right? So this is minus 10 by root 2 plus 1. Minus 10 by root 2 plus 1. Any corrections? I can write this is 10, 5 2s up, right? Yeah, same answer I'm getting. 1 minus 5 into 2 by root 2. That is equal to 1 minus 5 root 2. 1 minus 5 root 2. This is one value. And same logic, f of xyz at b, that is 2x plus 3y plus z at b, that is equal to, this is 2 into 1 by root 2 plus 3 into 3 by root 2 plus 1 minus 1 by root 2, right? Okay, this is 2 plus 9, 11 by root 2, 11 by root 2 minus 1 by root 2 plus 1, that is 10 by root 2 plus 1, that is 1 plus 5 root 2, 1 plus 5 root 2. So at b, f is having max, and at a, f is having minimum. F is having minimum. This is one problem based on two conditions. And next one. Another one is rectangular box. Okay, let me take this book. Yeah, one more problem. Find the volume of the greatest rectangular parallelepiped. Greatest rectangular parallelepiped that can be inscribed. In the ellipsoid. That can be inscribed in the ellipsoid. Excuse me. నేను క్లాస్లో ఉన్నాను, మళ్ళీ మాట్లాడతాను. Half an hour. That can be inscribed in the ellipsoid x square by a square plus y square by b square plus z square by c square equal to 1. This problem is similar to our previous problem, rectangular box. Rectangular parallelepiped means rectangular box. Previous problem, rectangular box inscribed in a sphere. Now this is ellipsoid. See, just what is the ellipse in 2 dimension? Ellipse equation, x square by a square plus y square by b square equal to 1. So in 2 dimension, what is its shape? Ellipse shape. Exactly this. Ellipse shape, right? Now ellipsoid shape in 3 dimension, ellipsoid shape. Just consider like this. Okay, the shape of the ellipsoid, oval shape like this. This is x-axis, this is y-axis, and this is z-axis, and this is origin 0, 0, 0. Okay, now that means what? See, this xy plane, in xy this is x, this is y. In xy plane, what is the shape of the ellipsoid? Like this. I am considering like this. Actually this shape, this is the ellipse shape, but I have considered only this part. Actually total is there, but in 3 dimension I can show only this much. Now this is origin, and what is inscribed in this one? A rectangular box is inscribed. A rectangular box is inscribed in this one. Okay, So same logic like previous, this much distance is x. So obviously here also same distance you will get. The figure is not suitable. Okay, not correct here. So what is the dimensions of the rectangular parallelepiped? 2x, 2y, 2z. Same logic. Let 2x, 2y, 2z be the dimensions of the rectangular parallelepiped, or simply I can write rectangular box, which is inscribed in the, this is the condition, which is inscribed in the ellipsoid, which is inscribed in the ellipsoid, x square by a square plus y square by b square plus z square by c square equal to 1. Okay, therefore what I have to maximize? Find the volume of the greatest rectangular parallelepiped. So volume of the rectangular parallelepiped or rectangular box, you can write, is V equal to how much? 2x, 2y, 2z, right? That is 8xyz. 8xyz. Now we have to maximize this volume. We have to maximize this volume. V subject to the condition. What is the condition? Subject to the condition. Condition is what? X square by a square plus y square by b square plus z square by c square equal to 1. So what is my Lagrange's function? Therefore, define the Lagrange's function. Define the Lagrange's function L as L of only one condition is here. So lambda is enough. What I have to maximize? The volume subject to what condition? This ellipsoid. X square by b square, z square by c square minus 1. Take this as 1. So the necessary conditions for maximum are dou L by dou x equal to 0. First condition. Dou L by dou y 0. Dou L by dou z 0. And with respect to multiplier, dou L by dou lambda 0. With respect to multiplier, dou L by dou lambda 0. Now, what this becomes? First one. Dou L by dou x equal to 0 implies 8yz plus 2x by a square equal to 0. Second condition, right? Just derivatives. Dou L by dou y 0. It is 8xz plus 2y by b square equal to 0. Equation 3. B square. Next. Third one.
2y into lambda. 2y into lambda by b square, no sir.
Dou L by dou x. Lambda will be there. Compulsory. Lambda. Right. Dou L by dou z equal to 0 implies dou z by dou z equal to 0 implies this is what 8xy plus 2z lambda by c square equal to 0. Equation 4. And last one, dou L by dou lambda equal to 0 is nothing but the condition, that is ellipsoid, x square by y square plus y square by b square plus z square by c square equal to 1. Equation 5. Now for solving this, see, in first equation 8yz, third equation 8xz. So let me multiply 2 into x minus 3 into y. That gives 8xyz, 8xyz cancelled. The remaining part is 2x square lambda by a square minus 2y square lambda by b square equal to 0. Lambda never 0. Therefore, I can take 2 lambda is common. X square by a square minus y square by b square equal to 0. That gives what? x square by a square equal to y square by b square in bracket since lambda never 0 multiplier. This is the first condition we are getting. Coming to second one, same logic. Let me apply for these 3 and 4. Multiply 3 by y, 4 by z. Okay, multiply 3 by y minus 4 by z. What it gives? 8xyz, 8xyz gets cancelled. 2y square by b square lambda minus 2z square by c square lambda equal to 0. So 2 lambda is common. Y square by b square minus z square by c square equal to 0. That gives y square by b square equal to z square by c square. This is another condition, right? Therefore, what we have? X square by a square, what we have? Y square by b square. And y square by b square, what we have? Z square by c square. Substitute this in last equation. In equation, what is that equation? Ellipsoid, this condition. Equation 5. Okay. So 5 implies x square by a square, y square by b square, z square by c square equal to 1. Now, x square by a square is what? Z square by c square. Convert into single variable. This is also z square by c square. This is also z square by c square equal to 1. So 3z square equal to c square. So z equal to what? C by root 3. C by root 3. Similarly, what I am getting, if instead of replacing in terms of z, if I replace in terms of x, similarly, if we replace every term in 5 into x into y's, what I'm getting? 3y square by b square you will get equal to 1, isn't it? So y equal to what? B by root 3. Similarly, 3x square by a square, every term in terms of x, I'm getting x, this one, x equal to a by root 3. So what is the stationary point? Therefore, stationary point is what? X, y, z is equal to a by root 3, b by root 3, c by root 3. Therefore, what is the maximum volume is equal to 8xyz. So this is 8abc by root 3 root 3. 8abc by 3 root 3. This is another model problem. Any doubts in this one? Just simplification. What is this? One time you replace x square by a square, y square by b square in terms of z. Everything in terms of z. Next one, replace x square by a square, z square by c square in terms of y. Then you will get this 3y square by b square. Then put y square by b square, z square by c square equal to x square by a square. Then you will get this 3x square by a square equal to 1. Okay. This is one model. And let me tell you one other problem. Yeah. So let's, if u equal to a cube x square, b cube y square, c cube z square, where x to the power of minus 1, y to the power of minus 1, z to the power of minus 1 equal to 1. Show that the stationary value, of u is given by x equal to sigma a by a, y equal to sigma a by b, z equal to sigma a by c. Solution. What is the given function here? Function is u equal to a cube in place of f, this is given, b cube y square, c cube z square. And the conditions are, what are the conditions? Only one condition is given now. Condition is 1 by x plus 1 by y plus 1 by z equal to 1. Therefore, what is Lagrange's function? I'm giving shortly. You have to write in examination every step. This is a cube x square plus b cube y square plus c cube z square plus lambda into 1 by x plus 1 by y plus 1 by z minus 1. 1 by z minus 1. Therefore, what are the first condition? Dou L by dou x equals 0. Firstly, I'm doing 2a cube x minus lambda by x square with respect to x, isn't it? Right? Next one, dou L by dou y equal to 0. 2b cube y minus lambda by y square equal to 0. 1 by y derivative minus 1 by y square. Dou L by dou z equal to 0 implies 2c cube z minus lambda by z square equal to 0. And lastly, dou L by dou lambda means this derivative 1. So remaining is the given condition. 1 by y plus 1 by z equal to 1. This is 1, 2, 3, 4. Now solve these equations one by one. Solve these equations. How to solve? How you can solve this equation? Come on, anyone? Anyone? First one, 2a cube x equal to how much? Lambda x square. From this, what is x cube equal to lambda by 2a cube? Is it correct? Or yeah, I can write directly. What is lambda equal to? It is better if I get in terms of x, y, z. Even if I get lambda, then what is the required? X equal to lambda power 1 by cube, 2 power 1 by cube a. If I put x, y, z after getting x, y, z, substitute in this equation, I will get lambda value. Isn't it right? Let me try in that way. So what is x equal to lambda power 1 by 3 by 2 power 1 by 3 a. This is x value. So similarly, what is y value? Lambda power 1 by 3, 2 power 1 by 3 b. And z value, equation 3 gives lambda power 1 by 3, 2 power 1 by 3 c. Right? Substitute x, y, z in 4. 4 implies, what is 4? 1 by x plus 1 by y plus 1 by z equal to 1. This implies 1 by x, that is 2 power 1 by 3 a by lambda power 1 by 3 reverse 2 power 1 by 3 b by lambda power 1 by 3 plus 2 power 1 by 3 c by lambda power 1 by 3 equal to 1. Done? So 2 power 1 by 3 by lambda power 1 by 3 is common. So a plus b plus c equal to 1. So what is the lambda value? Lambda power 1 by 3 equal to 2 power 1 by 3 of a plus b plus c. A plus b plus c. So what is lambda equal to 2 of a plus b plus c whole cube? Is it correct? If lambda is this one, therefore what is x value? What is x? X is lambda power 1 by 3, 2 power 1 by 3a. So this is enough. Lambda power 1 by 3, this is enough. What is x value? Lambda power 1 by 3, 2 power 1 by 3a. So if I substitute lambda power 1 by 3, this is a plus b plus c by 2 power 1 by 3a. So this cancel. This x value is what? A plus b plus c by a. A plus b plus c in cyclic form, I can write sigma a by b. Done? Similarly, what is y value? What is y value? Lambda power 1 by 3 by 2 power 1 by 3 b. What is this? Lambda power 1 by 3. If I substitute, I'm getting a plus b plus c by b. That is sigma a by b. Similarly, what is z equal to? Lambda power 1 by 3 by 2 power 1 by 3 c. So substituting lambda power 1 by 3, 2 power 1 by 3 gets cancelled, sigma a by c. This is the problem. Okay, and take assignment problems in Lagranges multipliers method. If x, y, z equal to 8, find the values of x, y, z for which u equal to 5xyz by x plus 2y plus 4z is a maximum. Okay, so condition is given here, function is given here. In function, in place of xyz, you substitute 8. So function becomes what? 40 by x plus 2y plus 4z. Okay, this is one. And second one. Find the minimum value of x square plus y square plus z square, given that ax plus by plus cz equal to p. Okay, next one. The sum of three numbers is constant. The sum of three numbers is constant. That means x plus y plus z equal to a. Okay, prove that their product, that means x into y into z, their product is maximum when they are equal. That means xyz is the function which is to be maximized subject to what condition? X plus y plus z equal to a. Apply Lagrange's method, you will get x equal to y equal to z. Next one. The temperature capital T at any point x, y, z in space is capital T equal to 400 x, y, z square. Finding highest temperature. Find the highest temperature on the surface of the unit sphere x square plus y square plus z square equal to 1. And fifth one, find the stationary values means point of u equal to x square plus y square plus z square subject to ax square plus by square plus cz square equal to 1. And one more condition is also given. Two condition problem here. My plus nz equal to 0. One distance problem will be there. Where is that? Yeah. The sixth problem, solved problem in textbook. Try this. Find the maximum and the minimum. Distances of the point 3, 4, 12 from the sphere x square plus y square plus z square equal to 4. And one more solved problem based on this distance. Yeah. Seventh, last problem. Find the shortest distance find the shortest distance between the line y equal to 10 minus 2x and the ellipse x square by 4 plus y square by 9 equal to 1. Okay, this problem two condition problem. This problem is two condition problem. What is this? Just I'm giving hint for this problem. This is also solved problem in textbooks. What is that? Let xy be the point on the ellipse. And u comma v be the point on the line. Why? Because see the question. What is this? Find the shortest distance between the line and the ellipse. Therefore, what is the distance? What is the distance between these 2 points? Distance is, I'm considering this as f of x comma u comma v. What is the formula? Distance between 2 points, x minus u whole square, y minus v whole square, under root will be there. But I'm removing under root. Why? Because if this is maximized or this is minimized, the square root is also minimized or maximized. So no need to consider square root. I'm considering distance as without square root. Subject to what conditions? Distance is subject to the conditions. What are the conditions? First one is what? Phi 1 I will take the ellipse condition, x square by y square plus y square by 9 equal to 1. First condition. And second condition is what? Phi 2 of uv. This uv point is on the line. What is the line? What is the line here? Line is 2x plus y equal to 10. Okay, so this becomes 2u plus v equal to 10. Okay, therefore what is L becomes? L, x, y, z. How many parameters? You will get 2 parameters. And what is the minimized function? The distance y minus v whole square plus lambda 1 into the first condition minus 1 plus lambda 2 into the second condition 2u plus v minus 10. So what are the necessary conditions? Dou L by dou x equal to 0, 1. Dou L by dou y equal to 0, another one. X, y, uv, not z is there, uv are there. Next, dou L by dou u equal to 0. Next one, dou L by dou v equal to 0. Dou L by dou lambda 1, 0. Dou L by dou lambda 2, 0. You find all these equations and solve them. Get the point x comma y and u comma v. Get the point x comma y and u comma v. Okay, that's it. And find the distance between the 2 points, whichever is minimum, that is the answer. Okay, this is completely Lagrange's multipliers method. With this, third unit is finished.